Good evening everyone. We are here to give presentation on our project titled Divyahasta Gesture Vocalizer for Mute Community. My name is Fani Kulkarni and my team members are Gitanjali, Swaranjali and Nikita, and our project guide is Dr. B.D. Fulpagaso. Divyahast is derived from Sanskrit, where Divya stands for magic and Hast stands for hand, and it is also derived from Divyangan, which is used to represent the disabled people. This is the outline of our presentation. Mute people use sign language to communicate with each other. They face problem when they communicate with people who can hear and speak. Divyahast is a device which removes this communication barrier. Now I hand over the presentation proceeding to Nikita.
Objective and the scope. The main objective of our project is the system which is mainly focuses on removing the barriers of the communication between the mute people and the people who does not familiar with the concept of the sign languages, so that the messages to that the dumb person is trying to relay is understandable to the person with no knowledge of the sign languages, to develop an efficient and effective device. Successfully implement the method to find the gestures. The future scope is the device is more portable because of the battery is used, and by introducing the different languages, so the flexibility is obtained.
Next is the problem statement. To design a device to help communication between mute person's sign language and other persons. Literature survey is the most important component of the project. Before designing and starting our project, we have to refer the work done by the researchers. This helps to overcome the limitation. We have referred the following research papers. First is sign language to speech conversion. In this system, flex sensors play the major role in performing the gestures. The number of gestures that can be converted to speech here are limited. Voice for the mute. This system was presented as a solution for the conversion of images into sound. Image processing techniques are used, but the accuracy is less as it does not give full degree of freedom for the hand movement. It requires more computation time. Next is hand gesture recognition and voice conversion system for dumb people. In this, PIC microcontroller, that is peripheral interface controller, is used. It has less number of instructions, so the length of the program is big. The computation will be slow as the program memory is not accessible in PIC. Next is AVR-based embedded system for speech-impaired people. In this system, flex sensors and accelerometers are used. Flex sensors are arranged only on 3 fingers of hand and accelerometer on wrist. Zigbee module is used for wireless connectivity. The computation time of the system is increased as data transfer rate of Zigbee is less. Next is SignPro, an application suite for deaf and dumb. This system uses 4 different approaches based on the methods used for gesture, but the accuracy is less and the gestures are limited.
Architectural diagram. Architecture provides functionality attributes. It consists of 3 layers: data access layer, business logic layer, and user interface layer. Data access layer, it contains the flex sensors and accelerometer. Flex sensors are used to measure the deflection. Accelerometer is used for acceleration. Then second is business logic layer. Business logic layer contains the Arduino Uno ATmega, which is a microcontroller. Third layer is the user interface layer. It contains the Bluetooth and the mobile phone. Bluetooth module is a wireless module which is helps to data exchange between the mobile phone and Arduino Uno. Next is now algorithmic approach. Start first, we have to set the baud rate. Then we have to give the input with the help of flex sensors and the accelerometer. Now these signals are sent to the Arduino Uno. Then data dynamic time warping algorithm is applied on these signals, and DTW algorithm helps to recognize the gesture, and it sends to the mobile phone with the help of Bluetooth module. Next.
System specification. These are the hardware requirements we are used in our project. Arduino ATmega 2560 microcontroller, flex sensors, HC05 Bluetooth module, Android phone, and the accelerometer. Also, we have used the software requirement are as follows: Windows operating system for the client, Android 4.0, Arduino IDE, programming languages like the C++.
Proteus simulation software is a well-known tool for circuit simulation. In view of COVID, though our hardware and project is ready, presently the hardware is not accessible. So we used Proteus to simulate our project. Now as you can see the screen, this is the Proteus software. These are the flex sensors. This is the Arduino module. This is the Bluetooth HC05 module, and this is the virtual terminal. The organization of the flex sensors represents as followed. The rightmost flex sensor represents the thumb, the next flex sensor represents the forefinger, the next flex sensor represents the middle finger, the next flex sensor represents the ring finger, and the last flex sensor represents the little finger. Now let us look at the chart of American Sign Language. Now let us focus on the symbol Y. Now to represent the symbol Y, we have to bend three fingers. That is the forefinger, middle finger and the ring finger. Now let us look at the simulation for the same, that is Y symbol. We have to enable these flex sensors. Now I am disabling this rightmost flex sensor and enabling the other flex sensors. Now I'll run the simulation. Now you can see the output Y on my virtual terminal. The same output Y is visible on my mobile app and it is also audible. Now when I click this text to voice button, the output Y is also audible. Now first I'll select the Bluetooth connection. The output Y will be visible.
Y.
It is also audible. Now I'll stop the simulation. Now let us focus on the symbol B. Now to represent the symbol B, we have to bend only the thumb. Now let us look at the simulation for this symbol B. Now we'll enable the rightmost flex sensor which represents the thumb and disable all other flex sensors. Now I'll run the simulation. The output B is visible on my virtual terminal and the same output B will be visible on my mobile app. And it will also be audible.
P.
Now I'll stop the simulation. Now let us focus on the symbol A. Now to represent the symbol A, we have to bend all other fingers except the thumb. Now let us look at the simulation for this symbol. Now I'll disable this rightmost flex sensor and enable all other flex sensors. Now I'll run the simulation. The output A is visible on my virtual terminal. The same output A will be visible on my mobile. I'll select the Bluetooth connection. And it will also be audible, output A. Now I'll stop the simulation. The same mechanism works for all other symbols.
These are the actual results for different alphabets. Here 1 indicates the enable the flex sensor and 0 indicates the disable the flex sensor. We will see next simulation results for different alphabets. These all are generated with the help of simulation.
Conclusion, we conclude that the communication barrier can be eliminated. This system converts the sign languages into the voice, which is easily understandable by the blind people and the normal people. So this system is useful for the deaf and the dumb people to communicate with the normal people. The combination of the flex sensors and the accelerometer to detect the gestures.
We published a paper in UGC CARE approved journal by name the International Journal of Analytical and Experimental Model Analysis, and ISSN number is 08869367.
The following are the references and these are the best papers.
Thank you.